Good day, students. Welcome to a pre-quiz review clip to get you ready for the quiz. It's going to be a mixture of logarithm and exponent problems. Let's go ahead and take a look at question number one. Question one, you're asked to write the following expression. Using rational exponents. Using rational exponents. Okay? So in this problem, in this number, we have the fourth root of 9x squared y to the fifth. Okay? So we're going to use the nth root property to express this using rational exponents. So using the nth root property, this can be expressed as 9x squared y to the fifth. Since it is the fourth root, it can be written as the power raised to the power 1 over 4. Okay? So now we're going to use the power of a product of powers property next. Remember, if a number does not have a power, the default power is 1. Okay? So what I'm going to do is I'm going to distribute this 1/4 to all the powers. I'm going to be multiplying them 1/4 by all these powers. Okay? So when I multiply, I'm going to have 9 to the 1/4. X to the 2 times 1 over 4 is 2 over 4. And then 5 times 1 over 4 is 5 over 4. Okay, you can look at these as 2 over 1, 5 over 1, and then 1 over 1, and just multiply across. Okay, wherever we can reduce, we reduce. If we can't, we'll leave it alone. So this is not cannot be reduced, so we have 9 to the 1/4. 2 over 4 can be reduced to 1/2, x to the 1/2, and then y remains as y to the 5 over 4. Okay, so there goes your answer. All right, with that in mind, let's move on to question number 2. In problem 2, it's another exponential problem. Simplify the third root of the square root of 343. Okay? So if we can express this as a rational exponent, then it will be easier for us to compute what this nested radical expression is. So we're going to start from the exterior using the nth root property. This can be expressed as the square root of 343 raised to the 1/3 power. All right. Now this radical does not have any number in front. That means it's going to be a 2. And now using the nth root property in the interior again, this is going to become 343 raised to the 1/2, and then the whole thing raised to the 1/3. All right. Now we're going to use the power of a power property to resolve this radical. This power is out here, so we're going to basically multiply this power times that power on the inside. So we have 343 raised to the 1/6 power. Okay. Now, let's see if I can express 343 as a power, okay? So to do that, I'm going to take 343 to the side, and I'm going to find the decomposition of 343 and express it as a power. All right, so I know 7 goes into 343. 7 goes into 343 49 times. And then 7 goes into 49 7 times, okay? So 343 written as a power is 7 to the 3rd power. Okay, so now I'm going to express this power as 7 to the 3rd raised to the 1/6. Okay, now I'm going to use the power of power property, just basically multiply powers. This is going to become 7 to the 3 over 6. Now I can reduce this by dividing the top and bottom by 3. So this basically becomes 7 to the 1 over 2. I can use the nth root property to express this as a square root of 7. So there goes the simplified form. Okay? All right. Now let's move on to question number 3. For question 3, we have the logarithmic problem if log base 4 of 3 is approximately 0.7925 and log base 4 of 4 is equal to 1, find log base 4 of 48. Okay? So to do this, all we just have to do is express log base 48, log base 4 of 48 using my ingredients, or using these two logs. So using the uh, product or quotient of these two, a combination of 3 and 4, if I can use them to generate 48, then that will be perfect. And I'll substitute their respective logarithmic values. All right? So let's break down 48 using 4 and 3. See what we can do here. I can take out 3 from 48. I'll be left with 16. Okay? Now, 3 doesn't go here because the sum is 7 and 3 doesn't go into 7. So I can take out a 4. 4 goes here 4 times. So I can express 48 as 3 times 4 times 4, which is the same thing as 3 times 4 squared. Alright? So now I'm going to express this logarithm as log base 4 of 3 times 4 squared. Okay? Now what I'm going to do next is I'm going to use the product property of logarithms to decompose this. Remember, when you're multiplying the arguments, you're going to be adding the logarithms. Alright, so I'm going to have log base 4 of 3 times becomes a plus log base 4 of 4 squared. Okay, let me make my exponent a little bit higher. 4 squared. Okay, now this exponent, I'm going to power it down. Power down, and then we're going to have, this is going to become log base 4 of 3 plus 2 log base 4 of 4. Now we can substitute their approximate values. Log base 4 of 3 is 0.7925 plus, we have a 2 here, log base 4 of 4 is just 1. Okay? So this logarithm is approximately 0.7925 plus 2. The final answer is 2.7925. Alright, so that's the approximate value of log base 4 of 48. Okay? So there you have it. Alright, with that in mind, we're going to advance to question number 4. In question 4, we're asked to solve a logarithmic equation. So we're going to solve the equation log base 2 of 7 plus log base 2 of x equals log base 2 of 49. Okay? Now we have two logs on the left, so they must be condensed. So we're going to condense these using the product property of logarithms. So this is going to become the log of the product of these two arguments, the 7 and the x. So it's going to be log base log base 2 of 7 times x, which is 7x, equals log base 2 of 49. Alright, now since we have one log on the left and on the right for the same base, we're going to eliminate the bases using 2 as our basis for exponentiation. Okay, so I'm going to put a big 2 on the left and a big 2 on the right, and I'm going to have a little log base 2 of 7x equals, and then 2 to the little log base 2 of 49. Okay, so since logarithms and exponents are inverses, these ones cancel each other out. So on the left side we have 7x equals, on the right side it's when the logarithms cancel each other out, equals 49. Divide both sides by 7, and then our final answer x equals 7. Alright, so there goes your answer for number 4. Alright, let's take a look at the last question. We're going to be simplifying an exponent with a rational power. So for number 5, the goal is to simplify 81 raised to the 3/4 power. Okay. The easiest way to evaluate this is to express 81 as a power, and then we can use the power of power property to simplify. Okay. So take 81 and break it down. 8 plus 1 is 9. 3 goes into 9, so I know 3 goes into 81. 3 goes into 81 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. So 81 is basically 3 to the 4th power. Alright, so this becomes 3 to the 4th raised to the 3/4. Now we have a power of a power, so we just simply multiply powers. So this becomes 3 to the 12 over 4, which equals 3 to the 3rd power, because 12 over 4 is 3. 3 to the 3rd power is 27, and there goes your final result. Alright, so there you have it. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. You can also share the contents of this video with your friends via Facebook or Twitter. More videos coming from algebra.com. Thanks again and have a wonderful day.